Okay, we've got a longer integral here today. We have the integral of x over 1 minus 5x squared multiplied by the square root of 2 over 1 plus 5x squared minus 1. And now the first thing I noticed here was this minus 1 under the square root is kind of out of place. So I decided to combine these two parts under the square root into one fraction. So we'll still have this x over 1 minus 5x squared out here in the front. But to combine this into one fraction, what I did was I just multiplied this 1 by 1 plus 5x squared over 1 plus 5x squared. That way, just to get a common denominator. And so in doing that, our common denominator will be 1 plus 5x squared. And in the numerator, we'll have 2 minus 1 plus 5x squared. Then dx. And so what we want to do here, we just want to distribute this negative into both of these terms and then simplify. So we'll still have x over 1 minus 5x squared. But under the square root, 2 minus 1 is just going to give us 1. And then distributing this minus into the 5x squared, it will just be a minus 5x squared now. And still over 1 plus 5x squared dx. And what we want to do here is I'm going to erase the square root, but I'm going to rewrite that square root as the square root of the numerator over the square root of the denominator. The reason for doing this is, notice, over here in this first term, the denominator is 1 minus 5x squared. Over here, in the numerator, the term is the square root of 1 minus 5x squared. So what we could do is we could actually cancel both of these, except this one doesn't completely go away, the one in the denominator, because this is to the power of 1. Over here, a square root means it's to the power of 1/2. So essentially, canceling this is just going to turn this one over here into under a square root. Next step, what we're going to want to do is we have the integral of x over the square root of 1 minus 5x squared times basically 1 over the square root of 1 plus 5x squared. And so because both the terms in the denominator are being multiplied and they're both under a square root, we can use a property that allows us to combine them all into under one square root. Still multiply together, but under one square root. So that will change our integral into the integral of x over 1 minus 5x squared times 1 plus 5x squared, where both of these terms are under the square root in the denominator. And what we can notice here, if we remember our difference of squares formula, a squared minus b squared equals a plus b times a minus b, we actually have that, the expanded version right here, where a is 1 and then b is 5x squared, because we have 1 minus 5x squared times 1 plus 5x squared. So what we're going to do is, because we have this kind of have half the equation, we're going to rewrite it as this half of the equation. And so that will give us x over the square root of 1 squared minus 5x squared dx. And I don't actually want to simplify this 5x squared or anything. The reason is because we're going to do a u sub right now. We're going to let u equal 5x squared, and that means du will equal just, it will equal 10x. Yeah, du equals 10x. And so because of that, if we actually do our u substitution now, we don't have a 10x, but we can manufacture a constant. So we have that 10, we just have to multiply by 1/10 on the outside. So if we plug in the substitution, that will be 1/10 times the integral of 1 over the square root of 1 minus u squared du. And if you recognize, this integral is actually a formula. The integral of 1 over the square root of 1 minus u squared, that is just going to give us arc sine of u. And don't forget, we have this 1/10 out front, so we're going to have to account for that here. So our answer is 1/10 arc sine of u, or if we actually plug back in what u equals, we will have that our answer is 1/10 arc sine of 5x squared. It's an indefinite integral, so don't forget your plus d, and that is our answer.